Hello, everyone. That's another episode of the Our Customer Highlights and also just podcast with great people in manufacturing. So I have Raymond from Polyspectra with me today. Hi, Raymond.
Hey, thanks for having me.
Absolutely, absolutely. So you have a lot of exciting stuff going on, I guess, with your new project, with your new material invention. So yeah, share more with us about that.
Sure. Yeah, right now we're in the middle of a month-long Kickstarter launch of a new resin called Core Zero, which for us has been 4,000 days in the making. And we're a materials company founded on some new chemistry that I invented when I was getting my PhD at Caltech. For folks listening, I don't know, materials take a long time. And so, I about 10 years ago, one of my mentors told me, hey, it takes 10 years to bring a new material to market. And I thought, yeah, I got this. I could do it in 5, no problem. And in some ways we did in the early introductions, but now it's basically been 10 years. So it's been a fun ride. And yeah, the main thing for us with Core Zero that's kind of different is, all of our products are very focused on like high performance, high working temperature, chemical stability, durability, weathering, ductility, all of these things. And for various reasons, including just like the price point that we're able to provide them at, but also some of the safety requirements for handling, it's really only been, let's say, appropriate to use in like an industrial setting or a lab setting or, a much more like high-end, like kind of commercial setting. So we made a lot of progress on making it work on hardware that's much more affordable. But then at the end of the day, it's like if that hardware is in a building that costs $1 million a year to run, then it's not really able to like help as many people. So the big breakthrough with Core Zero was really around safety. And so the properties are very similar to the other products that we have in terms of being this, very high working temperature, very high toughness, high impact strength material, but now with the ability to actually safely process it, in a home workshop.
Yeah. So you're saying that you're mainly focusing on the community of makers. So basically those who, how we can call them, so it's semi-professional or basically like those who still professionally can produce the parts with the materials, but not at the facility scale kind of the way. So how you...
Yeah. I mean, I think Core Zero right now, we have been kind of quietly previewing Core Zero with some of our, government and Fortune 500 customers. So it's not to say that the folks who can use the other resin obviously can use Core Zero too, and there are benefits there. But yeah, I think with the Kickstarter in particular, the thesis was really around maybe like prosumer might be like the word that you're searching for there, where this shouldn't be like the first resin that you ever print. It should, you should have some experience with resin printing. And I think that the folks who are doing it, are printing with resin, are realizing like, hey, this is very cool for prototyping, but I can't actually manufacture an end use part with it. I think that's the kind of person that would be the most excited about what's possible with Core Zero. So yeah, I think a big part of the thought process around the Kickstarter was actually like, why do people do Kickstarter for physical goods, for durable goods, right? It's to pay for injection molding tooling. It's like,
Sure.
like even really, even people who have huge audiences, who are very successful, run profitable businesses. Like there's this example, one Kickstarter I backed from this guy, Pat Flynn, who's like a digital marketing guy, millionaire, like everything profitable. But when he wanted everything software really, and like information products, and even though he could easily have footed the bill for it, he's like, no, like we're gonna do a Kickstarter with $100,000 minimum because I have to, like we do all the prototyping, but like to pay for the tooling and the manufacturing run, that's the only way to do it. And so a big part of the thought process was just like, well, if you could directly print like the end use component, that's ready to go, right? Then the kind of person who would be excited by that, empowered by that, able to move faster, cheaper, would be the kind of person who would start a Kickstarter.
Right. Exactly. And I mean, you have some options to fund your project like outside the Kickstarter, again, get a loan or something like that. But obviously, there's a lot of downsides, not only the interest rate, But also like with a Kickstarter, obviously you're getting the exposure, you're getting a lot of the excited users, your users of your material, users of your service, whatever. And just overall, it's not only funding, but also like maybe even at some point proof of concept that you can get from the audience that was involved from the funding perspective, was involved in your project. So I'm always was a big fan of the companies that run and launch everything in Kickstarter, because again that's so nice thing that they can be involved in that from the from that perspective, and also like get the first sample of the whatever you launch on Kickstarter.
Yeah.
So it's a great platform, I guess. Very good
Yeah.
platform for
Yeah, I think so. And I think that, we'll see. Like obviously we're working really hard and we hope it's successful. And I think that it's one of these things where it's like you don't know until you try it, right?
Exactly.
And I think that we have this thesis that like the kind of person who would want to start a Kickstarter would value this, would want to benefit from this, would be excited by it. And then I think the counter to that which is maybe just like interesting to talk about too, is there's also like a ton of totally bogus 3D printing and like CNC and laser cutting things that have been launched on Kickstarter. And so I think the counter to that is like, and again, this I don't think you can find out any other way than doing it, right? Is like, well, the people who might be excited about that might just be really burnt by all the ones that didn't ship, by all the ones that were 3 years late and then it didn't work when they actually got it, or they shipped, but it wasn't remotely living up to the promise of the marketing video. And so, I think that in some ways like that's kind of where our tagline, like make it real, which is our kind of just do it Polyspectra, it came from, is, hey, everybody's excited about 3D printing. The vision that we're interested in and excited about isn't really any different than what gets everybody excited about 3D printing. But then so much of the time, the solution actually falls short of the promise. And in our view, a big part of that is just the material's durability, right? Like the printers are cheap enough, they're fast enough, the resolution's good enough. Some accuracy is getting there, like it depends on kind of the context, but it can be good enough. But then it's like, if it breaks on day one, or like after a week in use, it's like completely deformed or warped, then what are you going to do with it, right? So yeah, I mean, that's like the thesis that we founded the company on, was really, well, with durable materials, then now you could actually transform 3D printing into additive manufacturing.
Right. Okay. 3D printing into additive manufacturing. So basically, we're thinking about those terms as 3D printing broadly as a technology, and additive manufacturing is actually when it's become more commercialized, I guess.
Sure,
Technology.
or like end use production, right? And like in recent times, the people jump up and down shouting serial production, or engineering grade, and then it's like, it's an industry where someone always sort of takes the term and like kind of abuses it for actually, I won't say who it was, but when 3D Systems first coined additive manufacturing, there were a number of people within 3D Systems, this is like back in the, I don't know, like early 90s, who were like, no, we can't call it additive manufacturing because it's just rapid prototyping. Like we aren't actually manufacturing the end use thing. But the marketing team won that argument. And so I think, and again, not to like pick on them in particular, I think most of the industry is at fault with this, but it's like, I think we've basically been living a version of that internal like mismatch between the promise and the reality, like over and over and over and over again since the 1983 invention of stereolithography.
That's very true. So, but talking about prosumers that are turning into the professional manufacturers or whatever. So, do you see that it's happening a lot now? So, I mean, do those people have any, I don't know, willpower or intention or whatever to actually build out of their garage, build a company, build a machine shop, build a 3D printing company out of that? Or they rather just want to do some prototyping for their home projects, like homegrown pets project, basically. So what do you see from your perspective?
Yeah, I think it's a little bit of a mix. What is very interesting in terms of people going into production of end use products is there's kind of this printers have gotten so cheap that the barrier is like lower than ever to getting started and trying something. And so in that sense, I think one thing I always say is like, well, what's the value of a 3D printer, right? It's like the value of the thing it can output, right? And so if the same printer can, with a different resin in it, can now all of a sudden print something. I mean, we have some cases in something like printed tooling, like additive tooling. There's a $400 printer you can get on Amazon, print a mold that would cost you like $1,200 or something from a CNC shop, running DigiFabster, of course. So what the ROI is like, one day or like one print you like make back. So I think there's something very interesting there where, like specifically, and again, without like breaking any confidentiality of our partners and customers, but there are more than a few folks that I know that are actually taking, instead of buying $100,000 printer that's branded for production, whatever, they literally are buying a $400 printer or maybe $1,000 resin printer, and they can buy lots of them and run them in parallel. And this part's kind of sad because it's very wasteful, but it's literally cheaper for them to run that thing until it breaks and throw it out and get a new one. And by the time it breaks, the new one will be, a little bit better, higher resolution, all this stuff. And so then you can literally, like, there's no CapEx to amortize on your factory, right? So like our joke with Core Zero is like, if you have a freezer, a microwave, and a resin printer, you have a factory. You're just missing Core Zero. That's like the sales pitch. But I think that there are more and more people that are kind of realizing that if they, if they can figure out the design for additive and they can find the right material, that actually the advantage of 3D printing is that the CapEx cost or the capital equipment up front can be really, really extremely low. Right. And so, and again, to the point where like you can get it with 1-day shipping on Amazon and potentially have an ROI in 1 day or a week or something crazy like that. So that is, I think, a really interesting evolution and a big inflection point for the whole industry.
Yeah, I think so. I think so too. And I see it not only in additive manufacturing industry, but again in machining, and sheet metals too. Basically, what I would like to call all of this is just basically people do more with less, from the equipment perspective, from everything. Something that, funny enough, again, something that kind of AI promised us, like, next 1 billion company will be run by like one person. So I think it really resonates with something that in manufacturing can be true, because again, at the end of the day, yes, you can now have almost production equipment in your garage, and you can basically produce, of course not like mass production, nothing like that, but you can definitely produce small batches. You can do production quality, and you really can do more with less. And I think maybe it's not something that scales with like enormous speed, but at least it shows that it's possible. It's possible to do a lot of the things locally, which is, again, that's one of the topic, like, kind of made in US, that for me, it's really important. I mean, it's important regardless of the country, but again, something that when you can produce something in your country and label it that it's made in US, I mean, it's kind of very proud thing, for the people. And that's something that I would hope that excites a lot of the people even get into manufacturing, because they can do that. They can, and that's something that I think happening, again, probably slowly, of course. But again, what I see is, even though manufacturing industry in the US is like, I mean, on the paper, it's 20,000 machine shops. including 3D printing companies, of course. But at the same time, it looks like it's a lot of the new shops that's coming into the market, running by, younger guys that either acquire some sort of legacy shops or buy, some cheap or used equipment, use CNC machines, or, build out of the sort of 3D printing farm, kind of the setup like that. And they're starting to build, they're starting to machine, they're starting to produce. So
Yeah.
I think it's happening. It's slowly, but it's happening.
Yeah. So a few things on that. Yeah. First, the hat, which is only available to our Kickstarter backers. Make America Great at Manufacturing Again is bipartisan, but I think that you're onto something that's very important. And there's like a few kind of examples here that I want to talk about. Two that I thought of before we come on, and one that you made me think of with the used equipment thing. But the fact of the matter is, like, the vast majority of like new technology advancements, or like our outsized proportion, right, are in the US. And like someone from, I don't know, Germany or Japan is gonna like tell me I'm wrong, or China's catching up, all this stuff. But like, at least let's say in my lifetime, right, like that, like the US is like the place for invention and innovation, and we can't make any of the things that we invent. And this article is kind of dated now, but one of my favorite articles on this is called "America Can't Make a Kindle and Why That's a Problem." And it's from this guy named Willie Shih, who is now at Harvard Business School. And basically what he does is he takes the very first Kindle that ever came out from Amazon, he takes it apart, and he goes component by component, and he basically shows every single component in a Kindle is an American invention, including all the manufacturing processes like injection molding and the e-ink and all this stuff. And zero of them, not only zero were made in the US because Amazon chose to do it in Asia, it's actually zero can be made in the US. As in, like, you can't even... So yeah, there are a couple people that do injection molding still in the US, but to do the quality and the price point that you need for a Kindle, and which has like, very complex internal features that you can't see and a really nice surface finish, there's no one in the US that can do that and have it still be whatever, $3 or whatever it needs to be for the bill of materials to make sense. And so, again, this is like this guy Willie Shih, this is like his whole career is like, how do we, like, there's no way to get that back after you lose it. So whether we lost it, you want to blame it on like the labor arbitrage of cheaper labor overseas, or the environmental arbitrage of like, well, they don't really care as much about the environment in like China or India or something like that. And so you're like not seeing the cost of them ruining, their ecology, that it would be too expensive to do here for that reason, et cetera. Like, it doesn't really matter how you want to point to it. The fact of the matter is, like, you're not going to get it back, right? Yep. And I forget exactly which company it was, but like in the, I don't know, maybe 10 years ago, one of the big semiconductor companies thought, oh, we'll do a fab here in Texas, and they couldn't staff it. Yep. Because no one in Texas wants a job that a Foxconn worker has in China, right? And so I think the only way out is to not lose the next one, right? So if we invent some new additive manufacturing process, let's not lose the next one. We invent some new automation technique, some new AI technique, like, let's not lose the next one, right? There's no way to get back the thing that you lost. And I think the second thing here that's like more of the vicious cycle aspect to this, that is like, and this is like Nassim Taleb, who wrote The Black Swan, is probably his most famous book, but like, one of the things he talks about is when you outsource the manufacturing, you inevitably outsource the discovery, right? Yep. So this like trial and error, iterating, like learning things along the way, right? Well, so we basically said to China, like, hey, make everything for us. And now all of a sudden they're better than us at all kinds of things, including like automation and probably a lot of categories of 3D printing. Even if it's US brand, they're behind the scenes of all this stuff. A lot of chemicals are made in China, and they're better. They can do a better job at higher purity than any American company can now. And it's like, well, and now we're like, hey, let's add a tariff onto you. We don't like that anymore. It's like, wait a minute. No, we literally paid them to do this, and we paid them to get better at it. And so it's like, it's not, in some ways, I don't even think it's fair to like be upset about it, because like we literally
Yeah,
like handed them
very
this
true.
opportunity to do it. So I do think the only way I think the only way forward to like is not going to be like blocking, like, I mean, maybe for in some situations tariffs might make sense, but it's like if you have to go to a tariff, then it's too late. You know what I mean? And so what I'm much more interested in is like, okay, let's accelerate innovation here and let's not lose the next one. And let's figure out how to do advanced manufacturing here in a way that does make sense. And to this kind of idea around, well, can it make sense here? This huge difference in cost of labor, then I think automation is the only way out of
Yep.
that, right? And you could think of 3D printing as just one like category, right, of automation, but like the robots aren't going to like take our jobs. They're going to give us better jobs. Wouldn't you rather be like a robot engineer making $300,000 a year than like,
Yep.
yeah, you know, a button flipper, right? And so I think that we've been so afraid of a lot of these things for this like jobs, they're going to take our jobs. But then when we do that, we don't, like, no one knows how anything is made and no one knows that everything is made overseas, right? So I think the automation piece has to be a part of it. But the very last thing that I want to say, I'm sorry, like on one here, but this is kind of like I'm very passionate about this. Your comment on these new shops buying used equipment. So one of the things that I want to share that I found really interesting is, so my brother works at SpaceX and he's been there for a long time, is senior engineer there now. But when he first started grad school, I said we had just like missed Mars because of like a imperial to metric unit conversion, maybe like a year or two before he started there. And I said to my brother Paul, I said, please tell me that SpaceX is using metric, right? Because like it's so crazy that
Yeah.
we're still using imperial units and like messing things up because of that. And he said, no, they're not. And the reason why is that they could buy for like pennies on the dollar all of the manufacturing equipment, like heavy machinery to make rockets that's used, from like
Mm.
Northrop Grumman shutting different programs down, from Boeing, you know, Lockheed, all the classic Raytheon, all the classic like defense primes and aerospace primes. So whether it's like a NASA program or a DoD program, that like, so anyways, the thing that you said that reminded me of it is like, now we look at SpaceX and go, you know, oh, this is so high tech and you know, Elon's like a billionaire, blah, blah, blah. But like I mean, maybe he did it at a little bit of a different scale than what you're talking about, but like he started that company by buying used
Yeah.
equipment
Yep.
from the, you know, people who weren't using it anymore in the defense and aerospace industry. And that was like, and so like arguably his biggest innovation is actually just one of cost savings, right? And like
Yep.
they've been able to do a lot of things since then, but like the founding innovation of SpaceX was
Yep.
like buy used stuff and go do something valuable with it.
I think that that's extremely cool insight and just an example that it's not like flashy title when, you know, they saying, okay, so, you know, Elon Musk without any like engineering background, you know, now launching rockets to Mars and stuff like that. That's not the point. The point is his approach on that, right? So his approach,
Yeah.
like, yeah, started with the user equipment. Why not? Why not? If it's cost saving way, of course. And again, to your point, like that, unfortunately now, like US can't produce a lot of the things because of the, well, first it's expensive, and secondly, no talents, or talents just not willing to do that work. So that's interesting thing because like there's a lot of the money in software, and because software companies in most of the cases have better multipliers on the public market compared to manufacturing companies, I would guess. So all the money goes into software, or a
Yeah.
lot of the money goes into software. So my wish would be, of course, that in the next 10 years, maybe it's going to be shifting the focus into the more into manufacturing, and that maybe slightly artificially will make this industry very attractive to, well, investors, of course, too, but just maybe from multipliers perspective as well. Because again, once money is there, I mean, of course, because it's obviously more expensive to build anything in US, but you can train people, you can get people excited, you can get people love to do manufacturing and hard stuff. And again, like SpaceX, you know, good example, really good example that, you know, guys do a lot of things a lot of the things in the not in the software but in the hardware kind of. That's a good example for others. Obviously, it's the too big example, right? So you just don't need to think at that scale when you're just starting anything. You need to think in a small scale, like your example with use equipment. So like start something, yes, by just leveraging use equipment, and that's the way to go. That's basically the way to go. So I would like to see examples like that, in the news everywhere, rather than like, okay, so that's the billionaire building, rocket company without any, mechanical engineering background, something like that. So it needs to be more stories, foundational stories, where people talking about that stuff rather than just flashy titles. That's how you get people even more excited, because it's realistic. It's realistic start. It's not something like, okay, so he actually just sold PayPal and then starting to building something like people. Oh, okay, so he had some money. I mean, it's maybe inspiring to someone, but on the really ground level, you want to be excited about those foundational stories where they started from nothing, from just leveraging the tactics that anyone can use even without the money or with a little money.
Yeah.
So
Yeah, no, I think a few things here. Like maybe one last like Elon one, because I think it's like interesting, but just to like put him, say, oh, okay, arguably like the richest man in the world or second, I don't know, like I don't keep track of that stuff, but like there's this amazing video of Elon like out in the parking lot of SpaceX basically saying, okay, if capital is the bottleneck to us like making more, he's talking about the Raptor engine specifically, right? It's like if capital is really the bottleneck, well, I have capital. Here's whatever. Here's $100 million. Here's $1 billion. Give me 100 Raptors right now.
mm-hmm.
And he can't do it.
Yep.
Right. And so there are things where I think, we like without like nation level, global scale manufacturing infrastructure, right? Like even like, I think it kind of goes to your point of like the VCs are all investing in software because they want those returns, right? And we could talk about, well, now that software is like so easy to make, I think it's
Mm-hmm.
probably hard for a VC to get a return on it. But I think that there are things that money can't buy,
Yeah.
right? Or at least not
Yeah.
not easily. And like manufacturing capabilities and is one of those, because the supply chain is this insane global complex system, right?
Yeah.
So I think I just want to like wrap up the Elon thing with like, even whatever richest man in the world can't just demand at, like, oh, I want 1 million Raptor engines because I want this project to go faster. Like, it's just not possible. That's actually not the bottleneck in that design. And yeah, and then to make it more about, everyday people making their ideas real, I think that, and connect it now with this conversation we've been having about like software, one of our goals or ideas, right, with this idea of like make it real or actually make 3D printing into additive manufacturing is, if you can go from the CAD model on your computer to the end use part, right, in a couple hours on hardware that you can afford, maybe it's in your house, maybe it's not, maybe you click buy and it shows up the next day from a shop, right? Now you actually could have hardware look like software, right? So like hardware tomorrow can look like
Yeah.
software has looked in the past, where you can iterate very quickly. You can start basically selling the thing with an imperfect version and then iterate and improve along the way, instead of kind of waiting or outlaying, some huge amount of capital only to find out that no one wants that first version, that it wasn't good enough, right? And so I think to me, that's kind of been one of the theses of Polyspectra, was like, well, to make hardware look like software, a lot of the CAD stuff is there. It's fun. An 8-year-old can do, Tinkercad on an iPad or whatever,
Yep.
and like that's not hard anymore. But and you can, I mean, most schools have FDM 3D printers, right? And I mean, I don't know, there must be like 1 million resin 3D printers sold every year on the cheaper end of things. So all of that's out there and accessible, but why isn't it? Why is it just prototypes? And why, and so that was kind of the whole thesis, was like, well, if the material was durable enough, then the exact same stack of hardware and software can now output a manufacturing grade component. Well, hey, that's a factory.
Yeah. Yeah. Yeah.
And yeah, and then it lets you get started, and then it lets you kind of iterate and sell the smaller volumes, and then you can move on to the bigger ones, right? And I think that connects back to this idea of the Kickstarter of just like, hey, let your customers support you and get something out the door, right?
Yeah, and I think, which is crucial, very crucial, it is also like speed up the dopamine cycle in people, because again, you can actually create something and print it or produce that within, I don't know, hours, right? The
Yeah.
final product in hours. And as the being like a young inventor or the person who, very into product design, engineering, a young person, of course, if you can speed up this dopamine cycle and just get parts and get product like almost next day, and then starting to kind of taste the market, try the market, and maybe sell some of that's amazing, because that's something that's possible with software. And I mean, obviously with AI and stuff like that, it's even more possible. So you can basically code something and ship it like, okay, not next day, but with a very short period of time. So if the same thing is possible with physical products, well, it's perfect. It's perfect because again, so I would hope that this is something that will basically accelerate more engineers into the manufacturing, and just overall accelerate manufacturing, like interest people in manufacturing.
Yeah.
So I think that's important because again, like as you said, like just not enough people excited about manufacturing to basically run it on a national level, when people, instead of go into the financial school or lawyer school, whatever, go into manufacturing. But again,
Yeah.
it's complex thing. It's not just education, but it's also just excitement about everything. Like, at some point of time, obviously a lot of the people wanted to get to space, go to the moon and stuff like that. And kind of the same with manufacturing, because it's exciting thing when you actually can, I mean, first get excited from someone else project, someone else, launching the rockets into space, but also when you can do that without big money, big efforts, but with just your hands, your printer or the small machine, and go to the market with that. So that's perfect cycle, I guess. So maybe we are coming into the age where it's like not just possible, but that's the reality, and maybe that's the way how to just create more, even more buzz around manufacturing and get more people into that.
Yeah, totally. No, and if you're for people who are passionate, I mean, everything's there, right? I mean, we had one of the more fun projects that we worked on was with a high schooler. Now he's in college, but a high schooler named Ben Choi who came up with a brain-powered prosthetic robot arm by himself with by hacking one of these EEG headbands and putting a bunch of servos in a robot arm, and he could, with his brain, get it to go pick up a ball and toss it. And it's yeah, he was at a nice high school. Yeah, they had a 3D printer at the high school, right? But I mean, again, like a 16-year-old can invent a brain-powered robotic arm, and so I think that the tools really are there for people who want to do it, and it's not as expensive as it seems. And I think, to your point about the education piece, I do think that one of the things that's exciting and interesting to me about 3D printing is the idea that the vast majority of people have no idea how things are made, right? And okay, maybe you took wood shop or maybe something back in the day, but I think 3D printing is an opportunity for younger people to like think about and learn about, hey, well, how would, we all have ideas every day of like, oh man, I don't like this thing. What if I had a better one, right? But actually being able to have the agency to do something about that, right? It doesn't need to be super expensive anymore. You don't need, a PhD. You don't need $1 million, right? You can actually make your ideas real much more affordably than I think most people would think.
Yeah. And of course, the next question would be like logically, okay, so you are creating this new product. Maybe then you want to run your own, not a factory, but let's call it factory, it's small factory, building your own products, maybe then build someone else products. And obviously at some point you would want to make a business out of it, not just, the small factory, small machine shop. And to me, it looks like the only sort of reality, at least in the US, maybe not only in the US, but a few other countries, of course, as well, where labor is really expensive and talent's expensive, everything expensive. So It basically comes down to automation everything.
Mm-hmm.
And it's not just like, this thing like, okay, so let's automate everything. It's probably more about the discipline that's important when you're starting the business. So being very disciplined about the spending, about pretty much about everything, about yourself too, as well. And because in the US, it's now probably a requirement, to be disciplined about that. So, but the good thing, you have a lot of you have access to a lot of the tools on both
Mm-hmm.
hardware level and also like on the software level. Like you can automate a lot of the administrative tasks. You can also automate a lot of the things with production itself. And again, I mean, the idea of running like one-man shop or something like that. I think it's more than reality, and that's fine. That's fine for the people, and it should be very accessible for a lot of the people, and people need to like be very confident about themselves that it's possible. It's not like
Yeah.
the only way to build a business. You need to go loan the money or get money from VCs, starting to hiring people, starting to build the actual business. So no, actually, you can start with almost nothing and still, get to some scale with the business. And I think that's beautiful that it's more possible now than even 5 years ago, in 10 years ago. So
Yeah. Yeah. And on the pure software side, I mean, with some of these like AI coding tools, they're folks literally like, launch a new product in an afternoon,
yeah.
and that's pretty amazing and pretty crazy to see. And I think on this idea of automation, one thing, I don't know, this is maybe like a little bit more like philosophical or something, but I think one of the things that I, over the last like, year and a half, 2 years of really kind of learning more and pushing myself to be using AI, every single day. One of the things that I got thinking about a lot is kind of this idea of like a business as a function, right? And I think that, the you can think about, okay, well, what's a business, like what's the goal of a business, like create more value than like it charges for, right?
Mhm.
But then you can start to think about all these different things that I think, um, historically have been a person, right? Well, now instead of thinking about it like a role, we can think of it as like a job function, right? And so something, with kind of really, really, really thinking about it as a function or a process, like an algorithm, right? Then it doesn't mean that there are no people, but it basically means that you can actually leverage, like with a tool like DigiFabster, right, where there's no like non-deterministic AI stuff right in there, right? Like it can run an algorithm to say, okay, yeah, the walls are too thin, warn the customer, whatever. Oh, what's the best orientation for this part, right? And then with the kind of non-deterministic magic of LLMs, right, and ability to convert natural language into, function calls, convert natural languages into code, I think that there's this amazing opportunity to now say, okay, well, what are all of the requirements that we would even need to know to provide a quote to the customer, right?
Mhm.
And that doesn't necessarily maybe there's an AI agent that's helping say, I can't finish, right? Like, so we use DigiFabster, right? And a lot of the time it's like what takes us the longest time is just something that isn't represented in there, or isn't, the customer didn't say, oh, this little tiny thing you really have to pay attention to, right? But that kind of thing, I think, is becoming more and more and more automatable, right? Where you can now say, okay, well, there's a structured set of inputs that are required to generate a quote as an output, right?
Mhm.
And so now what's an AI assisted workflow to like fill out all of those requirements? Okay, we need to know if there's any like A surfaces that we have to care about. We need to know if there's any trap volumes or like really thin holes that we didn't see, things like that. So I don't know. To me, I am like, back to your point about like the smaller stuff or the solopreneur or the prosumer. I actually think I am really bullish on. There's an article I could probably find this and link to it. There's an article that kind of breaks down like this idea of like the $1 billion company by one person, and kind
Mhm.
of shows like that's kind of insane. Like maybe $1 billion valuation, but then, how do you get to like $100 million revenue on a single person? But I think the idea of like and we got talking about this a little bit before we jumped on the recording, right? But it's like the normal thing is to think like, oh, I need more money, right? Or I need more people. And then I need more money to go hire those more people, right? But it's like, no, actually, you don't. What you need is figure out if anyone is going to buy the thing that you want to sell, right? And obviously, you need to be honest about that. You don't want to like, sell something that you can't deliver or like have vaporware. That's a big problem of 3D printing in general as an industry. But I think that thinking through like whether there's people involved in the nodes or not, right? What is the function of the business where this kind of person pays X in this way, and how does that like cash flow work into the outcome of the product? And I think most people don't think about it that way. And I think that I myself am like again, coming from this like super deep tech chemistry innovation platform technology, raising $15 million to go like make this thing real, right? It's like, can I even challenge myself to like think differently, or think like, how can I do this faster? How could I actually like do the experiment on the market, run the scientific method, right, on the market to see, and only then, when you have that, then you can go solve the really hard thing, right?
I agree, completely agree. And again, because we know like the playbook now changes from the perspective of the fundraising and things like that. But again, it's pushed people to the same thing that I said before, like do more with less. And before, maybe you have less tools available for you to do that, but now there's no excuses to like, I can build a company because I need to hire like 10 people, 20 people, 100 people, whatever. So it's just more, can you be disciplined enough in the beginning to create the foundation of the company and the sales motion, obviously, because that's the key. So create this initial sales motion and then scale it up. So that's what the requirement now. But again, you have all possible tools and also channels now to do that, to to get this initial traction. And again, no excuses not to do that when you just started get the solopreneur or something like that. So that's, I think, the beauty of something that changed pretty recently, I guess, in the last maybe 10 years. And yes, it's a new playbook, of course. But I mean, it's to me, it's in a good way. It's just help you to create healthier business, more stable business, and just learn even faster, probably learn just faster, and build more important skills, in your skill set as an entrepreneur. Yeah, I mean, I think all those changes are for the good. Sure. Yeah, so some other interesting topic that I would like to touch on, and something that obviously, because we work a lot with very different machine shops and 3D printing organizations, and always trying to get understanding of, okay, so who's your customers, like who's your ideal customers, of course, what's the most profitable niche you're serving, right? And I mean, because in the machining and in the metalworking world, it was pretty much always was either defense or aerospace as the biggest customers most of the time, because again, they obviously have a lot of work to do. But also, I was always wondering, is it more, let's call it, civil applications that can get you to the get you to build big business, or at least like just profitable business, profitable machine shops? Like what about other niches, like talking about like oil and gas, talking about probably some farming equipment, maybe some go-kart engineering, whatever. Like it's a lot of the small niches, but the question is, can you really build machine shop or 3D printing company out of those niches? I mean, in comparison to like those heavily funded, basically defense or aerospace. So what's your thoughts on that?
Mm-hmm. Yeah, I mean, with defense and aero, there's a few things. Like one, they're just more zeros in their budgets, and so they're less price sensitive. Two, because of some of the security stuff, like it has to happen here, right? And so they know that they're going to be kind of paying extra, right, for some of that. And so again, I think that they're like a classic adopter of new manufacturing processes, a classic early adopter of advanced materials, right? And also kind of have, again, these sort of unique performance requirements or like constraints on like, hey, that like this file can't leave the United States, can only be seen by US citizens. And so there, I do think that it's like, it makes sense that that's a stable market, right, for this kind of thing. Outside of it, I'm a little bit less in touch with on the like CNC side of things, but the, one industry, for example, that is undergoing a lot of digitization where, there's milling and printing processes that are active and involved, is dental. Right. So basically, because there's no size 10 mouth and it needs to be unique for you, or in the case of something like a clear aligner like Invisalign, it's not just like unique to you, but then like every 2 weeks or every 3 weeks, it's like a new shape. Right. So their printing makes a lot of sense. Their, how fast can you go from the dental hygienist waving the wand around in your mouth to get the scan to like the treatment planning to the part in your mouth. And so I think that there are opportunities. So on the printing side, if you have something like that where there's this like mass customization need, right, or this unique shape, right, then you're not constantly battling against, injection molding, where someone might think something is really cool, but then at the end of the day, like that component's got to be $2, and so then the only way to get it is to mold it in Asia, right? For that price point. So I think dental is a good example of an industry where there's like enough like momentum and applications, and obviously it's like, some things in dental are insurance reimbursable, so it has that kind of healthcare extra couple of zeros, on it. And in some cases there are whole companies that just do chairside dental where they're trying to have the offices like make it themselves. There are other companies that say, no, that's silly. A dental lab, which is effectively like a dental product producing factory, right, is going to make those. And now it's more like, parts on demand kind of thing, that the dentist doesn't want to manage the 3D printer. They're going to just order the parts, have them delivered. And I think, which one's sort of the best or wins or gets more market share is like not really the point that I'm trying to make, but like that it's possible and able to do that. So that I think there are opportunities for that in other kinds of healthcare. I think there's also opportunities for that in other kinds of consumer products where people do want things to be unique or custom to them. But I do think that it's kind of tough there is this like huge momentum, right? Or like inertia, however you want to think about it, of just like, hey, I get something for very cheap because it was made overseas instantly, because now there's like same day shipping and I like want that. And so I think the challenge for folks who are kind of watching this, who are makers, who are engineers, who are coming up with their new ideas, is that like, well, then how do you find that kind of minimum viable audience that like cares enough about your unique one, right? And what's that value proposition that you can bring that makes it something that's, in this case of the custom one, it's like I really do want it to be custom. I don't want the one off the shelf, right? So maybe it's like, my brother just got married. He got like their, our last name in like a neon sign, at this, like, okay, that's not going to be on Amazon because there's like my last name's not that common as you can see, right? But that's not a huge business either. And so I think figuring that out of like, well, what is the, do you really need a market of one in terms of the shape? Are you making, what's the lot size of identical units that you're making, right? Yeah.
Yeah, I think to your point, I don't think we will see huge shift in injection molding, like shifting from Asia to US. No, I don't think we'll
No,
see
it's
that.
never coming back, right?
Yeah.
And in a lot of cases, like if that's the, I won't say who, but like there are a few folks in 3D printing who are like, if the competition is injection molding, then like I'm not even gonna have the conversation, right? because it's injection molding is amazing, right? It just that but I think most people don't understand the supply chain risk piece, right? And I think the sad thing, I mean, I think one of the most disappointing things to me about COVID was I think there was on the bright side of COVID, one of the things that happened a lot faster was just like we're doing, right? Like digital meetings, everyone going on Zoom, this idea of decoupling, like what's my job versus like what building do I sit with my butt in a chair, right? Like more remote work, more digitization of healthcare. Like those are like very cool things to come out of it. One of the things I think we totally missed the boat on, in particular in the US, is like the wake up call of like just how fragile all of our supply chains are, right?
Yep.
And this whole panic around like how do we make ventilators really fast, and then it was like, oh well, we don't need them anymore. Yeah, let's forget about that. And it's like, well, but wait, but what's the next thing that we can't make? And like,
Exactly.
is it gonna take, I hate to say it like this, but it's like, is it gonna take like a war with China for us to realize that we can't make anything anymore? We're completely screwed. Everything that everybody uses, whether it's the stuff you want to buy for yourself on Amazon, or, essential medical equipment or essential whatever, like transportation equipment or military equipment. I mean, come on, like we don't have a resilient infrastructure to make these things here. And so, what happens when China just says, yeah, we don't really feel like making that stuff for you anymore. And I think, I don't know. So to me, I think there was this huge missed opportunity with COVID for the federal government to be like, whoa, actually, this is so fragile, right? And for companies, the big OEMs, right, to say like, oh my God, like we need to invest in resiliency, like redundancy, right? And I don't think that happened really at all. I mean, it's still like I don't track this closely, but it's like you still have this, like, we're still feeling the lag for just in automotive manufacturing, for example. We went through this huge cycle of like, well, there were no cars made. Now there's no cars available. Now rental cars are insanely expensive and used cars are like worth a ridiculous amount. It's like, how long has it been? You know what I mean? Since the lockdown, but like those lags and delays are really long. And you could argue, well, did we really need all those cars in the first place? But I think you could do that for any specific item. But I think the point is like, well, again, it's like manufacturing resiliency, domestic manufacturing is like an insurance policy against whatever, whether it's these giant, tropical storms that we just had in North Carolina, whether it's a war, whether it's a pandemic. Like if you don't have the means of production, it's the like Karl Marx term for it, right? But it's like, you don't have the means of production, then like you're kind of screwed, right? And maybe you can buy your way out of it. And I think where I worry about for the US in particular is I think of that game of just like, well, we'll just like print more money to buy our way out of it, is kind of I don't know, maybe short-sighted to say the least. So
definitely, it's all about having this bulletproof critical components made at home. That's it. And it's regardless if it's like defense or military, it's also like a lot of the civil applications, of course, as you mentioned, like healthcare and some others. You need to have a maybe even slightly more than just a backup at home, with the production. It's really about that. And on the top of that, I guess, as the opportunities for entrepreneurs and for machinists, of course, I mean, we're talking about, yes, maybe it's a small batch manufacturing, some CNC parts that you can make, but you're not making just a CNC parts, you're making the final products and sell it with some premium on top of that. So that's the opportunity. That's the opportunity at home, because I'm pretty sure that is a lot of the people would be absolutely okay and willing to pay more in premium for the products that made here, and not only because it's like, proud moment, like, made in US, but also because it's like, in logistically, it's like, it's also like, it's maybe your neighbors doing something like that, or it's just super close by to you, like you can get it overnight. And it's a lot of the components out of that. But again, we're probably talking about like, just make small batch manufacturing, regardless if it's like 3D printed or machines. Just make it possible, make it work at home in the US. So that's, I think, critical. And that's absolutely possible. And like, yeah, obviously not a lot of the, but at least a few companies on the market show that, like, that who do a lot of the, like cars for us, Tesla again at home, with all the engineering, with all the machining at home. So it's all important. But again, I think it's kind of showing the way for others. It's possible. I mean, you can do it, and I think it should be inspired for people.
Yeah, let's
Yep.
make it real.
Absolutely. Let's make it real, for sure, for sure. Very cool. Yeah. Great to talk to you, Raymond. Yeah, as always. Yeah, let's make it real, and let's make makers into manufacturing. Let's help them with that, for sure.
There you go. Awesome. Hey, well, thanks for having me. It's really fun conversation, and yeah, super excited to be a part of the show today.
Awesome. Thank you so much. All right. See you.
Yep. Thank you.